The first problem, 6x plus 24, is a linear function. So I showed two methods for solving it. First method, you could factor out a 6 and you're going to get a quantity x plus 4. You divide both sides by 6 and you'll just end up with like an x plus 4 equals 0. Subtract both sides by 4 subtract 4 from both sides, you get x equals negative 4. Excuse me. Second method, I could start by subtracting 24 from both sides and then dividing by 6, and I'm going to get that same answer. Either method works, they're both perfectly fine. It's a linear function, so we might be more used to this second method here than we are to the first method. The first method is kind of what we're using more for quadratic forms, like we're going to see this one in number 2, where I'd have to say, oh, I need to factor out an x out of both terms, and I'm going to be left with an x plus 3. And that's important because now I can get an equation that's x equals 0 and another one that's x plus 3 equals 0. And I can subtract 3 from both sides and get an x equals negative 3. All right. For problem 3, this one's a good example of where I might want to do the box method because I got a middle number as well. And because I see a plus 8 there and a negative 9 in the middle, I know I'm going to need to have two negative signs there. And the factors of 8 that add to 9, there's 1 and 8, that adds to 9, 2 and 4, which doesn't, so that adds to 6. So it's got to be 1 and 8, minus 1x and minus 8x. And 1x and 8x make negative 9x. So this factors out to x minus 1 and x minus 8 equals 0. And then I work on each individual part. Add 1 to both sides, I get x equals 1, and on the other one I get x equals 8. So those are my two zeros, or my two x-intercepts for problem 3. For problem 4, of this 5x squared plus 20x, I factor out a 5x out of both terms. I'm going to be left with an x plus 4 equals 0. So I would get a 5x equals 0 for one part, and an x plus 4 equals 0 for the other part. So being able to recognize when I need to factor out an x is super important, and we had a couple different examples like that today. On the first one, I can divide both sides by 5, and I'm going to get 0 divided by 5. Well, it's still 0. On the second one, I can subtract 4 from both sides, and I get x equals negative 4. For problem 5, this is another one with an x on both parts. So I can factor out an x, and I'll end up with an x equals 0, and then a 2x minus 3 equals 0. I can add 3 to both sides, get 2x equals 3. So x equals 3 halves, or 1.5, or 1.5. But I like to leave it as a fraction for when I'm solving it as an exact answer. An improper fraction, 3 halves is perfectly fine. And then the last one here, x cubed minus 6x squared plus 5x. That x cubed looks a little scary, but it turns out I still have a factor of x in each term. So I could technically rewrite this as x squared minus 6x plus 5 equals 0. And now once you have it like that, you should know what you're supposed to do. Oh, I can write the first one as x equals 0. And then I have an x squared minus 6x plus 5 equals 0. And this one I can break down to the box method. The only factors of 5 are actually 1 and 5. And because it's a minus 6x, I know it's going to be x minus 5 and x minus 1. So I can write it as x minus 5 equals 0, x minus 1 equals 0. And I get x equals 5, x equals 1. So I end up with my three zeros here, because it was a third degree polynomial, so I should have 3 answers. I get x equals 0, x equals 5, x equals 1. We're going to start with today's 19th. Algebraic simplification of fractions. So it's like apply the same patterns and properties to these fraction problems that include variables. In many cases, this is a review of an AGS3 concept. All right, so write each fraction in simplest form. Show yourself your process. So what we're going to do today is we're going to be simplifying fractions. And what we have first is we have like A times B times C. That's kind of what this first one looks like, divided by C. And we want to get rid of like terms in numerators and denominators. So for example, C divided by C, that's just going to, those ones will go away. And what we're going to be left with is A times B. That's what number one would simplify to. Okay. Problem number two says A squared times B to the B cubed. So I could technically write it as 2A's and 3B's all over B squared. And then I have a B divided by a B that goes away and another B divided by a B that goes away. They're both in the numerator and denominator because B divided by B is 1. So every time I have a B in one term, I have a B in the other term as well. And what happens is I end up with A squared times B. That's what's left for number 2. Number 3, 8x squared over 16x to the 5th. So I'll write out 5 x's and then a y. And it looks like, yay, I've got 2 x's that are going to go away. So I'm going to have 3 x's left in the denominator. And my numerator is going to have an 8. But there's also an 8 and a 16, so 8 sixteenths can simplify too, right? 8 sixteenths should become a 1/2. So for this one, I should have 1 over 3x's, so x cubed y. That's what that one simplifies to. 1 over 2x cubed y. Okay, so I just kind of expand the whole thing out. And then I'm looking for like terms. And then I can go ahead and write it back down in a condensed form again. All right, last one here. Problem 4 says x plus 1 quantity squared over x plus 1. So I can only divide out entire quantities that are being multiplied or divided. That's really important to notice. So for example, on this one, I have a quantity x plus 1 in the numerator and a quantity x plus 1 in the denominator that go away. So I'm going to be left with just x plus 1 in the top. What I see a lot from students, though, is they'll have something like this, which is like x over x plus 1. And they'll say, hey, there's an x in the numerator and an x in the denominator. Don't do that, okay? Because the denominator is being added by 1. That's like if I actually put a value in there for x and said, like, let's say x is 2. So this is 2 over 2 plus 1. Well, what's 2 plus 1? That's 3, right? So this is technically 2/3. Is that the same thing as saying, oh, I can divide out the 2's and I'm going to be left with a 1 there, so I end up getting like a 1/2. Is 1/2 the same as 2/3? No, it's not. But that's what you're doing if you say, oh, I can divide out an x out of the numerator and denominator by itself like that. But the second one, that's a quantity x plus 1, so I can't just divide out just the x's. It's got to be the whole term or none of the term whenever there's addition or subtraction involved. Really, really important there. That's the most common mistake I see when we're trying to simplify fractions like this. All right, so just keep that in mind. Okay, so simplifying rational expressions. A rational expression is going to be in simplified form all right, if its numerator and denominator have no common factors other than plus or minus 1. To simplify a rational expression, we have to apply the following steps. All right, we're going to factor. So that's why we've been doing a lot of factoring practice, because we're going to factor the numerator and denominator first. That's the first step. Factor the numerator and denominator. And then we're going to divide out any factors that are common on both the numerator and denominator. That's what we just saw. So here's a good example where it says x squared plus 7x over x squared. And then we can factor that out to the numerator factors out to x times x plus 7. And the denominator we can just write as x times x. And then, hey, there's an x in the numerator and an x in the denominator that can be divided out. But notice the x plus 7 over x remains. There's no crossing out the other x. We already talked about that. That's not okay. So don't do that. Okay. So you cannot divide out the like terms in the third expression. That's really important. All right. So now we say simplify the following expression by dividing factors. So looking at the part A here, I have 40x plus 20. So I know I can pull a 20 out of both of them. And I'm going to be left with a 2x plus 1. That's the numerator. The denominator, I can pull a 10 out of both terms, and I'm going to be left with an x plus 3. And if I'm not sure, I can always try and distribute it back together. 20 times 2 is 40x. 20 times 1 is 20. 10 times x is 10x. 10 times 3 is 30. That's perfect. That's the first step. Go ahead and factor it. The second step, I see I have a 20 divided by 10 here. Well, 20 divided by 10 is just going to become a 2. So I have 2 times 2x plus 1 over x plus 3. And that looks like that's everything I can factor out. I can't really do anything with the 2x plus 1 and the x times 3. And then the last step would be to put it back together. So I'm going to put this 4 back in there and say, or this 2 back in there, and I'm going to get 4x plus 2 over x plus 3. And that is simplified. Okay? But I want to put it back together, just like I did in the first couple of examples where I had 3 x's in the denominator. I didn't just leave it as 3 x's, I rewrote it as x cubed. So I want to put it back into that condensed form if possible at the very end. All right. I want you guys to try examples B and C now. So do some factoring, both the numerators and denominators, and then see if you can simplify after the factoring is done. Okay, try it out. So for parts B and C, I start by factoring, all right, numerator and denominator respectively. And in part B, I can factor out a 2x out of the numerator, and I'm going to be left with an x plus 1. In the denominator, I'm going to look for, I'm going to get an x plus 3 and an x plus 1. One of the tricks with these types of problems is the simplifying is hopefully if I can simplify the numerator, I can find a similar multiplied value in the denominator. So in this case, it was an x plus 1. I knew there was going to be an x plus 1 in the numerator once I found it, so I was hoping there was going to be an x plus 1 in the denominator as well, and it turns out there was. So that's perfect. So now I end up with this 2x over x plus 3, and that's done. For the second one, part C, it's a difference of squares problem, so I end up with like an x plus square root of 4 and x minus square root of 4, which is x plus 2 and x minus 2. But unfortunately, I look at this and there's not much I can do. I can't really divide anything out. So I actually just have to put it back together and just say this one cannot be simplified, or I could say it's already simplified. Either way of describing that is perfectly fine. But yeah, it turns out that there's not a common factor that can come out of either part of C there. Okay, so for part B, we got the x squared plus 4x plus 3. If I were to, we just had a question on that real quick. If I were to do the box method for that problem, x squared plus 4x plus 3, the only possible factors of 3 are 3 and 1. And because it's a plus 3 and a plus 1, it has to work that way. So I'd get a positive 1x and a positive 3x, and 1x plus 3x equals 4x. So that's how I got the x plus 3 and x plus 1. And I also knew because the numerator was an x plus 1, I wanted to find an x plus 1 in the denominator as well, so that I could simplify something. And it happened to work out just nicely for me. So that's how I ended up with that part. Okay. 3 steps in simplifying rational expressions. We already talked about it, but I want to bring it up again. We're going to start each problem by factoring the numerator and denominator respectively. All right. My second step after I factor the numerator and denominator is I want to divide like terms. But remember, it's got to be entire multiplied like terms. Okay, just because there's an x in the numerator and an x in the denominator, if one of them is an x plus 5 or something, we can't just divide those x's out. And then the last part, I finish up by condensing my answer. Or putting it back together. I'll say putting the numerator and denominator back together. Okay, and just remember, like for example, for part C, I factored out the denominator to x plus 2 and x minus 2, but there's nothing that could be divided out. So I just said, okay, let's just put it back together then. And then we can leave it like that, okay? All right, so 4 more practice problems here. Give them a shot. I'm going to write down the answers in a minute here. But 4 practice problems, I want you guys to try your best to look for simplification process for these ones. The hint for number 4 I can give you is factor the numerator, and hopefully you'll get a similar term out of the denominator. That's the hint I can give you for when you're looking to factor that numerator and denominator there. For problem 1, we have an 8 in the numerator, and the denominator 4x plus 2. I can pull out a factor of 2 out of both terms in the denominator. So I should end up with a 2x plus 1. And then I have this 8 divided by 2. And that's going to leave me a 4 in the numerator and a 1 in the denominator. So I end up with 4 over 2x plus 1. And that's as simplified as that one's going to get. All right, I cannot divide that 4 and the 2x, even though it's really tempting to do that. For problem 2, I have an x plus 4 in the numerator, so I'm hoping that there's going to be an x plus 4 in the denominator as well. And it's one of those difference of squares problems, so I can do x plus square root of 16, x minus square root of 16, and the square root of 16 happens to be 4, which is nice. So I end up with an x plus 4 times an x minus 4. And because I have an x plus 4 in the numerator and denominator, that goes away, and I'm going to be left with a 1 in the numerator. So I get 1 over x minus 4. That'd be my simplified expression. Nothing to put back together, which is kind of nice. For problem 3, the numerator is going to be x squared minus 2x minus 3. So I'm going to need to subtract one term and add another term. It looks like this one's going to be x minus 3 and x plus 1. And I'm going to have a negative 3x here and a positive 1x there, and that would get me the negative 2x in the middle, so that's perfect. So my numerator now is x plus 1 times x minus 3. So that means when I'm breaking down the denominator, I'm hoping to see one of two things. I'm either hoping to see an x minus 3 in my denominator, or an x plus 1 in my denominator, because I want to be able to factor this and simplify it. So hopefully I can look for something like that. That's kind of like my cheap way of doing it. So when I break down the denominator, I just want to verify that I can do this x minus 3 or x plus 1. So let's start with like an x minus 3 over here. If I made one side x minus 3, that means the other side would have to be positive 2. And that would give me a negative 3x there and a positive 2x there. And that does make a negative x in the middle. That's perfect. And that's exactly what I want to see, because that means x minus 3 divided by x minus 3 goes away. And I'm left with x plus 1 over x plus 2. That's my simplified result. So I can kind of use that first part of problem 3 to help me answer the second part of problem 3, which is kind of nice. Because I was able to say, I hope there's an x minus 3 there, and there was. I could have done that with an x plus 1 as well and tried it out. All right. And this is where problem 4, I think this is where the trick for problem 4 is going to come in very handy. Starting with the top, 2x squared plus 10x, I can factor out 2x out of that top term, and I'm going to be left with an x plus 5. And that x plus 5 is the big part. Now I want to see, okay, can I get an x plus 5 out of this expression, which is 3x squared plus 16x plus 5. Well, if this side's x plus 5, this side has to be a 3x plus 1. And that's how I can hopefully factor it. And if it's a plus 1, I get a positive 5 there. That's good. And then 3x times x is 3x squared. 3x times 5 is 15x. X times 1 is a 1x. 15x plus 1x equals 16x, so it checks out. Awesome. I just saved myself a ton of time. I don't need to work through all these possibilities that could be factored. If I notice there's an x plus 5 in the numerator, and I try that one first, hopefully I get an x plus 5 in the denominator. If I try the x plus 5 and it doesn't work, then this thing's not factorable. And what I end up with is 2x over 3x plus 1. All right. And that covers problem 4 there. All right. And just like that, we are done for the day. What you guys are going to do on your assignment, the first 3 problems match the rational expression with the simplified form. So figure out which one looks like it's the simplified form of the previous one. And then problems 4 through 12 are just practicing this, trying to simplify as much as possible. We have 25 minutes left in class, so that should be, honestly, that should be enough time. That's 2 minutes per problem to get this assignment done right now and get it turned in at 9:40. All right. Anyway, thanks so much, you guys. Have a great day.